as usual, my camera froze, so I'm going to try again. Back to number 50. This is the graph of f prime. It says on the bottom right here that for 49, right above that, it says that f is always continuous, even at those points where f prime doesn't exist. Part A says, where is f increasing? F increases where f prime is positive. This graph of the derivative is always above the x-axis, so the answer is from 0 to 3. Again, this is the graph of f prime. Don't be confused where x is 1 and x is 2. It's like the quiz from today. X equals 1 just shows that the second derivative at 1 doesn't exist. Please ignore that point of discontinuity. Please ignore that point of discontinuity. So the answer for A is from 0 to 3. Now, B says, where is f decreasing? Nowhere, because f prime is always positive. Let's go on to C. Local min, local max. Based on the first derivative test, this never changes signs. So remind yourself that there's two places where local extrema occur, at a critical point or at an endpoint. I have no critical points. I have nowhere where f prime changes signs. So let's look at my endpoint 0. My endpoint 0, because my f prime is increasing, my left endpoint, if my function is increasing, my left endpoint ends up being a local min. At x equals 3, again, my derivative is always increasing. So the right endpoint, if my function's increasing, the right endpoint, my right endpoint ends up being a local max. So in summary, there's a local maximum at x equals 3, and there's a local minimum at x equals 0.